Factor the expression x squared plus 6x plus 5, and using this result, find the x-intercepts of y equals x squared plus 6x plus 5. Well, let's start by factoring the expression. It's always useful to remember that when we're factoring an expression that has an x squared term and a constant at the end, so this constant 5, whenever we face an expression that looks like this, what the end result will be something like this. It'll look like x plus a multiplied by x plus b, where a and b are some values. And so what we're trying to do is we're trying to factor this expression such that it looks something like this, but we don't yet know what a and b are going to be here. Well, another useful thing to remember here is let's examine what happens when we expand this out. Considering we want to factor this expression, what happens when we expand this expression? Well, let's expand it now. So x multiplied by x, that's x squared. X multiplied by positive b, that's plus bx. A multiplied by x, that's plus ax. And a multiplied by b is plus ab. So this is just an expanded version of this bracketed expression. And we've got some common terms here, bx and ax, so let's rewrite this by collecting those common terms. We've got x squared. We could write b plus a, but let's write a plus b just because a comes before b. It's the same either way. A plus b times x plus ab. So this is an expanded form of this bracketed expression here. And what's interesting about this is this form looks very similar to this form. So we've got an x squared out the front with a coefficient of 1, and x squared here with a coefficient of 1. And then we've got 6x here, we've got a plus bx here, plus 5 here, and plus ab here. In other words, if we can find some values of a and b such that, a plus b equals 6, and also ab equals 5, then we could write this expression as this bracketed expression and replace the a and b variables here with whatever the solution is to this set of simultaneous equations. So let's go ahead and do that. Let's consider this second expression, a times b equals 5. So what are the different factors of 5? We could have a equals 1 and b equals 5. If that were the case, we'd have 1 times 5, and that would equal 5. Or alternatively, we could have a equals minus 1 and b equals minus 5, and that would also equal 5. Those are pretty much these are the only factors of 5 that we could insert as a and b to get 5. Alternatively, here we have a plus b equals 6. Well, if we look at what our values for a and b were that we tested here, 1 plus 5, well, that does equal 6. What about minus 1 plus minus 5? Well, minus 1 plus minus 5 equals minus 6 or negative 6. So consequently, a equals 1 and b equals 5. That satisfies this rule. Alternatively, we could have b equals 1 and a equals 5. It would be the same thing because a and b are interchangeable here. But either way, a equals 1 and b equals 5 satisfies this equation. In other words, what this is saying is that if we were to write x plus 1, so there's x plus a, where a is equal to 1, and then x plus 5, so x plus b, where b is equal to 5. If we were to expand this out, we would get the same expression. Let's just test it to see. If we expand this expression out, x times x is x squared. X times 5 is 5x, so plus 5x. 1 times x is x, 5x here, plus x. 1 times 5 is 5. And if we collect our common terms here, we'd get x squared plus 6x plus 5, which is exactly the same as the original expression. So in other words, this is the factored form, x plus 1 all times x plus 5. That's the factored form of this original expression, x plus 6x plus 5. Great, so we can put this in a box to say that this is our factored expression. Okay, let's consider the second part of this question. Using this result, find the x-intercepts of y equals x squared plus 6x plus 5. And this expression here represents a quadratic function. So it's asked us to use this result to find the x-intercepts. Well, let's recall what the x-intercepts are. The x-intercepts are the points at which the graph either touches or crosses the x-axis. And by definition, that occurs when y equals 0. In other words, we need to find the x values that we could substitute into this equation such that y equals 0. Or alternatively, we could write that as x squared plus 6x plus 5 equals 0. So it's asking us for x values that we could input into this equation such that this holds true. Of course, here we've got y equals 0. That's why I've written this. Okay, well, it's asked us to use the result from above. So instead of writing x squared plus 6x plus 5, why don't we write this factored expression to see where that gets us? So we could easily write this as the same as x plus 1 multiplied by x plus 5 equals 0. And we need to solve this. So what are the x values we could input here such that this remains true? Well, if this first part of the equation, this bracketed section, if this were equal to 0, then the whole expression would be equal to 0, because 0 times anything is 0. Also, if this part were equal to 0, then even if this were not equal to 0, 0 times anything is 0. So again, if this part of this x plus 5 were equal to 0, then this whole expression would equal 0. In other words, the solutions to this equation occur when x plus 1 equals 0, or when x plus 5 equals 0. We can simplify this out. If we subtract 1 from both sides here, we get x equals negative 1. Or if we subtract 5 from both sides here, we get x equals negative 5. In other words, if we were to substitute x equals negative 1 into this equation, or x equals negative 5 into this equation, we will get y equals 0, which corresponds to an x-intercept. In other words, the two x-intercepts are the points -1, 0. So this is the x coordinate and then the y coordinate of the x-intercept, remembering that y equals 0. That would be one x-intercept, and another x-intercept would be -5 and 0. So when you're facing a quadratic function where you can see that you can factor the expression, this is always a good way to go about finding the x-intercepts. That is, first factor the expression, and then once you've found that factored expression, consider what the x-intercepts are by considering what x values you could substitute into that expression to make it equal to 0. So we can just put this in a box, and these are the two x-intercepts.